we have subtraction of algebraic fractions. We know that we need to have the same denominator to do this. So first, let's see what we have here. We have m squared minus n squared. First, so we have difference of two perfect squares. So first we can rewrite this, that this is 2 over m minus n times m plus n. I just use formula that a squared minus b squared, this is a minus b times a plus b. A is equal m and n is equal b in this example. Next, we have in the denominator 2n squared minus 3nm plus m squared. If we forgot about m, we can try to factorize our trinomial by grouping method. Let me copy the second denominator. This is 2m n, of course, square minus 3nm plus m square. So let me copy this trinomial without m. So will be 2n squared minus 3n plus, this is like invisible 1. So now we have general quadratic trinomial. We will try to factorize our trinomial using grouping method. So first we have to multiply coefficient before n squared by constant. So 2 times 1 is 2. And next we have to find two numbers which I multiply and I will have 2. And when I add these two numbers, I have to have negative 3 coefficient before n. So it will be negative 2 and negative 1. When I add this, I will have negative 3. When I multiply, it will be 2. So now, what we will do? We will copy first expression 2n squared, and now negative 3nm we can rewrite using these two numbers, minus 2nm and minus 1nm is 3nm, negative 3nm, exactly the same what we have at the beginning. And we have plus m squared. Now, from the first two expressions, we can factorize 2n, so will be n minus m. And from the last two, we can factorize negative m. So in parentheses will be, because I have 1 here, so I can put this 1 here, doesn't change anything because negative 1m is negative m. And now in parentheses, whatever left, so will be n, and we will have minus m. Negative 1m times negative m give me positive m squared. Now in parentheses we have the same term n minus m, so we can factorize this and whatever left will be in the second parenthesis. So 2n minus 1m is just m. So we factorize the second denominator. We will try to do the same with the third denominator. So let me copy this denominator. We have m squared minus m n minus 2m squared. Let's forget about now n. Of course, here is n. We have n squared. So we will have m squared minus m minus 2. And now, because coefficient before n is positive 1, so we need to find two numbers which I multiply and I will have negative 2, and when I add these two numbers I will have coefficient before m is negative 1. So it will be negative 2 and 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So now we can rewrite our third denominator. M squared we will copy, and now negative mn, we can rewrite that this is, we have first number negative 2mn, and next we have 1. So I'll only add mn. And we copy 2n squared. You see, I didn't change anything because negative 2mn plus 1mn is negative mn, still the same. But now I have 4 expressions, and from the first 2 expressions I can factorize m, and in parentheses I will have m minus 2n, and from the last 2 expressions I can factorize n, and I will have in parentheses m minus 2n. I don't have to put this 1 because when I am multiplying by 1 it still will be m. So now we can factorize m minus 2n, and in the second parenthesis will be whatever left, so m plus n. So now we can rewrite our last 2 algebraic fractions. The numerator we copy and the denominator will be for the second, of course, the numerator will be n minus m times 2n minus m, and for the third numerator we have to copy, and the denominator is that. So we have m minus 2n times n plus m. So now this is equal because we have here n minus m, and in the first denominator we have m minus n. So what I will do, we can factorize negative sign and we will have exactly the same expression here. We just change this to m minus n. So let me copy first fraction. We have 2 over m minus n times m plus n. Next we have minus, numerator we copy 1, and now I will factorize negative sign from this term. So I will have negatives like 1 in parentheses, and inside will be negative n plus m, because negative and negative give me positive, so will be the same, and negative and positive give me negative m. And I have here n minus m, and the rest I will copy, times 2n minus m, and the third fraction we will copy, so it will be 3 over m, and again we have here m minus 2n, and here we have 2n minus m. So I will factorize negative sign from this term, and I will get exactly what I have here. So let's do this. Negative 1 I will factorize, so we will have negative m plus 2n now, and we have to copy n plus m. So now this is equal, let me rewrite first fraction. We have m minus n times m plus n, and now we have negative sign in the denominator and negative sign before this whole fraction, so negative and negative give me positive, and we will have 1 over, I will put positive number variable first, so it will be m minus n, and we have 2n minus m, copy first, and again negative and negative give me positive, so it will be plus, and we have 3 over, first I will put positive expression, 2n minus m, and we copy n plus m. Now we see that we have the same in parentheses, m minus n, 2n minus m, and 2n minus m. So it will be easier to find the least common denominator. How we do this? We have to just copy the first expression in parentheses, m minus n, and copy the second. And now we check what we have else in the last two denominators. We have m minus n, yes. We have m plus n, yes. And what else we have? 2n minus m and 2n minus m. So we have to multiply the first denominator by 2n minus m to have the same denominator. Let's check now. First denominator has m minus n times m plus n. So the beginning is the same, but now we add this term. So I have to multiply, if I multiply this numerator by m minus m, I have to multiply numerator by the same expression. And next, the second denominator, we have m minus n, 2n minus m, okay, but we don't have m plus n, so I will multiply this denominator by m plus n. If I multiply this denominator, I have to multiply numerator by m plus n. And the last denominator we have 2n minus n, okay, n plus m, but we don't have n minus n, so I have to multiply denominator by m minus n, and if I multiply the denominator, I have to multiply numerator by the same expression. So now we have our denominator, and we have to do multiplication in the numerators. So we have 2 times 2n minus m, so it will be 4n minus 2m, and we have plus 1 times m plus n, so it will be m plus n. And I will keep the same order of terms like I have in the first denominators. So first I put m minus n times m plus n times 2n minus m plus, and the last denominator, same order, so m minus n times m plus n and times 2n minus m, and we have to do multiplication. 3 times m is 3m, 3 times negative n is negative 3n. Now when we have the same denominators, we copy the denominator, m minus n, m plus n, and 2n minus m, and we have to just add. We have at the beginning subtraction, but we have subtraction that now when we find the common denominator, we change this subtraction to addition, and now we have to just add 3 algebraic fractions. So we have to copy first numerator, we have plus the second numerator, and plus the third, 3m minus 3n. Now we have to combine the like terms in the numerator, and the numerator we will copy. For n we have and n, so it will be 5n minus 3n is 2n, and we have 2m, negative 2m, positive, so it will be negative m, plus 3m, so it will be positive 2m. So now we can factorize 2 in the numerator, so we will have n plus m over m minus n times m plus n times 2n minus m. So this is equal. We have n plus m, and in the denominator m plus n is the same. We can add addition, we can change the order, so we can rewrite our numerator will be 2 times m plus n over m minus n times m plus n times 2n minus m. Now we have multiplication in the numerator, and in the denominator we can reduce this whole expression. Will be 1, and now we have 2 times 1 is 2 over m minus n times 2n minus m. This is my solution.